horizontally. When container is accelerating horizontally. In that case, if I say I have a container and it is accelerating horizontally with acceleration A, let's suppose it has some liquid filled of density rho. Now you can see in this that if I take a small layer or a small mass of the liquid, let's suppose I take this length I'll take as x, area I'll take as a, and density is. Now as the container is moving towards right with acceleration a, so the liquid that is present inside the container is also moving with the same acceleration. Okay, कंटेनर अगर आगे जा रहा है तो कंटेनर के साथ साथ लिक्विड भी उसी एक्सेलरेशन से आगे जा रहा है, करेक्ट है ना?
करेक्ट करेक्ट।
तो कंटेनर पे तो फोर्स हम लगा रहे हैं, इसलिए उसके पास एक्सेलरेशन है। लिक्विड में भी कुछ फोर्स लगना चाहिए, बिकॉज विदाउट फोर्स देयर कैन नॉट बी एनी एक्सेलरेशन। इफ आई से दैट ऑन दिस साइड pressure is P1 here, and this side like pressure is P2. So due to pressure here, force F1 will be P1 into area, and here force towards left will be P2 into A. So F1 is acting towards right, F2 is acting towards left, but the system is moving towards right. It means right side force should be greater. F1 should be greater than F2. So if I write here the net force F net acting on the mass of liquid that I have taken, it will be F1 minus F2. And net force is equal to mass into acceleration. F1 is P1A minus P2A. P1A is greater. Now mass I can write as density into volume. Density. Volume I can write area into x, that is length. This is volume, into A is equals to P1 minus P2 into A. A cancel. So we can say P1 minus P2 is equals to rho AX. That is the pressure difference. You can also say that pressure at 1 is greater than pressure 2. How much greater? It is rho AX. This much pressure is greater. P1 equals to P2 plus rho X. So conclusion is, if the container is accelerating towards right, then left side pressure is more. That means on that side where it is moving, that direction pressure will be less. You can see that P2, P1 is greater than P2 by rho AX. Understood?
Yes sir, understood.
And pressure is more, so height will be also more. So liquid will not remain horizontal. This side liquid will have more depth, and this side liquid will have less depth. So the container, if inside the container you will find the shape of the liquid is inclined. This side height will be more, and this side height will be less. Understood?
Understood.
So जिस तरफ वो मूव करेगा विद एक्सेलरेशन, उधर लिक्विड का लेवल कम हो जाएगा। और ये तभी होगा जब कंटेनर मूव कर रहा है विद सम एक्सेलरेशन। इफ द कंटेनर इज मूविंग विद कांस्टेंट वेलोसिटी, देन लेवल विल रिमेन हॉरिजॉन्टल, नो चेंज। It should have some kind of acceleration, then only the level will be different, or we can say pressure will be different. Please copy it, Neil.
Okay, sir. Yes, sir. Done.
Okay. Now, if I make it diagram again to discuss few more things. So we know that if this container is moving towards right with acceleration A, the liquid level is like this. This side is more liquid, this side is less height. Let's suppose this is H1 and this is H2. At this point, pressure is P1. At this point, pressure is P2. And the length of this container is L. So I can write P1 is equals to P2 plus rho A L. There I have taken X. Now I am taking the complete length L. And if I draw this incline and make, let's suppose this angle of inclination is theta. So this will be also L, and this height will be h1 minus h2. So I can use what is the angle of inclination, tan theta equal to opposite, that is h1 minus h2 by L. So I can use this equation also. If I consider this incline here separately, let's suppose here I am drawing the just the inclination part I am drawing here. So I know that if I take here one particle having mass m, so it mg force will be acting downward, and as system is going towards right with acceleration a, so pseudo force will be acting towards left, that is ma. This angle is also theta, so here I can take ma cos theta. This I am talking about one liquid particle of mass m that I'll take here. But here this same diagram I am making here little bigger to explain you. And this side force will be mg sine theta. That means this m is acted upon two forces here. This force is ma cos theta, and down the plane is mg sine theta. So if I make both equal, ma cos, because liquid is at equilibrium, liquid is not flowing inside the container, so forces will be equal. So you can write that a by g is also equal to tan theta. So tan theta is this also, tan theta is this also. So if I combining, I can use for angle of inclination, tan theta is equals to h1 minus h2 by L, and is also equal to a by g. So you can correlate these three formulas, and whatever they ask, you can find. Understood? Neil, you got it?
Yes, sir. Understood.
Yeah,
Yes,
please
sir.
go.
Yes, sir, done. Yes, sir, done.
What, Neil?
Sir, done, done. The notes.
Okay, what I'm saying that I'll repeat myself. I'm saying that have you observed that in the direction of acceleration level goes down and opposite to the acceleration level goes up? Have you observed that?
Yes, sir, I've observed.
So here you see if it is rotating, then rotate in case of rotation, acceleration is always directed towards the center. So at the center means the axis. So at the axis level goes down and away from the axis level goes up. That means the shape will be like this. You understood?
Understood.
So if I say this is the radius of the tube and where the I'll take this point as the origin. Let's suppose this I write x-axis, this I write as y-axis. So this is the maximum height. You can see this is the maximum height. That is h. To find the relation between this h and r, because it is not a straight line, it is a some curve condition is there. So I'll take a point here whose has a coordinate, and this point is rotating. This point means a small mass m I am taking. This point will rotate in this circle. I'll take its coordinate as xy. That means its height here is y and radius is x. So here I can say that this m is having one force pseudo force outside, that is m omega square x. M omega square r is centripetal force. Centripetal force is acting towards right, but pseudo force acting towards left. Acceleration is towards left, so the pseudo force will be towards right. And this angle you can take as theta. Now I'll again make it here separate. Okay, so this was the curve I am making to explain you better. And I'm saying that there is one particle, this is here center. So this particle is rotating in this path. Acceleration is inward, so pseudo force will be outward, that is m omega square x. X I have taken this radius. If I draw a incline here, this angle I take theta, this angle will be also theta. So this force will be m omega square x cos theta. And as mass m is there, so down the plane always mg sine theta is there. That means you can always use mg sine theta is going to be equal as m omega square x cos theta. In NEET, they don't ask very difficult question. Okay, this type of question uh, concept only I am telling. In NEET, they will only ask the relation that I'll tell you later. But how it is derived, you should also have slight concept. M you can cancel. Sine by cos is tan theta. So you can write here tan theta is equals to omega square x by g. Now, as I already discussed you the formula of tan theta. What was the formula of tan theta? It was a by g. Can you see this, Neil?
Yes, sir.
Tan theta equals to a by g, right?
Yes, it is.
And in circular motion, we know the any body is in circular motion, and if it is rotating with an angular speed omega, then it's and the radius is x. Then centripetal acceleration is omega square x. Omega square r is the formula for acceleration. So I have, you can directly, instead of doing all this, you can directly say that we already know that tan theta equals to a by g, and here a is centripetal, so I can directly write that tan theta equals to omega square x by g. This logic also you can use. Okay, understood?
Yes, sir.
Now, as straight line, tan theta is always same, but here curve theta keeps on changing. So tan theta, in place of tan theta, I am going to write dy by dx. That is the slope is equals to omega square x by g. So dy will be omega square by g. This will be x dx. Let's suppose the level increases from 0 to h, and distance can go up to the radius r. So you can have the relation that h is equals to, this is omega square, x will be x square by 2, you can put r square by 2, r square by 2. This formula application they can ask in NEET. So in this, you see that h is directly proportional to r square. R is the radius of the tube. Okay, and height is the difference of height at the center and at the edge. What is the height? That is I have done as h. So h, I am getting the formula is omega square r square by. Now you can write if you understood.
Okay, sir. Yes, sir. Done.
Okay. So this was accelerating container. If I say uh, a container is moving with constant velocity, no acceleration, then these formulas will not be applicable. It is only applicable when container is moving with some kind of acceleration. After this, we discuss about buoyancy, or we say that buoyant force. We also say this upthrust. What happens actually when a body is immersed in some kind of fluid? Here I am taking the liquid only, but it is also true for gases. And let's suppose one particle of some mass is immersed here. The liquid has a density rho, body has a density sigma. Now, the top part of the body is, let's suppose, at a depth h1. The bottom part of the body is at a depth h2. The liquid will apply one downward pressure here, and liquid will also apply upward pressure here. If I say here pressure is P1 and here pressure is P2, which pressure will be greater, नील? कौन सा प्रेशर ज्यादा होगा?
Uh,
P, yeah,
Basically, हाँ, buoyant pressure ज्यादा होएगा.
P1 या P2?
P2. P2.
P2 ज्यादा, क्योंकि डेप्थ, pressure depends upon depth. With depth increases, pressure also increases, right? Okay. And if I say this area of cross section is A, then you can say here force F1 and here force F2. So F1 I can write as P1 into A, and F2 I can write at P2 into A. And you said that F2 is greater, and P1 also I can write as rho G H1 into A, and this I can write as rho G H2 into A. So F2 is greater than F1, so I can find the net force is basically F2 minus F1. This net force is always upward. That's why it is called as upthrust. Net force is always upward. So this is called upthrust. F2 is rho GA. You can take common. This is H2 minus H1. H2 minus H1, you can take the height of the body itself. This is H. So I can write here, this is rho G A H. Area of the body, height of the body will give the volume of the body. So upthrust, that we also write as buoyant force. Buoyant force that we write as B is rho G V, density of the liquid, gravity, and volume of the body. Here one thing you have to be clear, that if the body is not completely immersed in the liquid, it is partially immersed. Let's suppose this type of immersion is there. Okay. So only I have to take this volume to find the buoyant force. That only we take that volume which is immersed in the body. That means complete formula should be B equals to density of liquid. Buoyant force formula is density of liquid multiplied by G and multiplied by uh, volume of body that is immersed in liquid, that is immersed in fluid. That volume only you have to take, not complete volume. If it is completely immersed, you can take complete volume, no problem. If it's partially immersed, then you have to use only that part of the body. So rho g v in. In means inside the liquid. That should be the formula. Understood? नील समझ में आया बाबू?
यस सर, समझ में आया।
ठीक है, लिखिए इसको। हाँ।
यस सर, डन।
Okay. So that is the concept of buoyancy. Always we use the formula B equals to density into G into that part of the volume which is inside the liquid. And density always we take liquid density. We don't take the body density. Okay.
Okay.
Now let's discuss about flotation. When the body is going to float in any kind of liquid. So if I say I have one liquid here and I have made one body to, I have just kept one body, immersed one body inside this liquid. So one force will be acting, the weight of the body that is downward. Other force will be the upthrust buoyant force. Now the conditions are, if I say what are the conditions here, first condition is if buoyant force is greater than the weight, then the body will float on the surface. Body will come on the surface. The body will float on the surface. Body will float on the surface of. Now, buoyant force means density of liquid into volume into G. Here it is completely immersed, so I have taken the complete volume. And density is the liquid rho. And let's suppose sigma is the density of the body. So density into volume into G is the weight. Vg cancel. So here I get a condition if the density of the liquid is greater than the density of the body, then first condition is applicable. The body will float on the surface. Second condition, let's suppose B is equal to W. Then the body stays in equilibrium. Stays in equilibrium. It will neither go up, neither go down. Equilibrium. And it will be fully submerged. It will be fully submerged in the liquid. So this is the condition when again buoyant force is rho L Vg is equal to sigma Vg. Vg cancel. So that is the condition when the density of the liquid is equal to density of the water. And the third condition is possible if buoyant force is less than W. So net force will be down, that means the body will sink. The body will sink. So this is again rho L Vg is less than sigma V Vg. So it gives that if the density of the liquid is less as the density of the body, then the body will sink. This is called principle of flotation. You understood all three conditions, Neil?
Yes, sir. Understood.
Is right.
Oh,
You have not done nil?
No, sir, last line.
Okay.
Yes, sir, done.
Okay. After this, we have Archimedes principle that we will discuss in the next class. Okay.
Okay, sir. Okay.
Bye.